Hello again, guys. So here we are in the second video about logics, okay? So remember that in the last video we were talking about the theory, about what a conjunction is, about how can we find a truth value, okay, for conjunction, and some easy examples, all right? So remember, you can find it in PowerPoint presentations from slide 9 to 11, okay? To 12, I'm sorry, from 9 to 12. Okay, and we finished the last video with this example. So remember, we had the following propositions. Here we have the proposition P, that is this, and the proposition Q, that is this. And we have to find the denial of P and Q. So we have to find the negation of P and Q by using this truth table, the same that I showed you before in the last video, okay? So we were finding this, and remember, we had the proposition P, this operation, 2 plus 3 plus 5 minus 8, and we found that it was 2, and 2 is less than 12 by following this statement, okay? So this proposition, 2 less than 12, it's of course true, okay? So we already have the first proposition, all right? And now we continued with the proposition Q, and here we have 1 over 3 plus 1 over 4 is greater than 5 over 3. And what did we do to solve this? Remember, to add unlike fractions. Here we have different denominators, and we have to get the same denominator, so we multiply by a number to get the LCD, all right? So in the first case, we multiply 1 times 4, that makes 4, and 3 times 4, that makes 12. In the second one, we multiply 1 times 3 and 4 times 3, okay? In the numerator, we have 3 over 12, okay? Because this is the denominator. And now, the next step, we have to compare by using this sign if this result is greater than 5 over 3. And how can we compare them? We have to get the same denominators and then compare the numerators. If we have a 3 here, we can get a 12. How can we do it? By multiplying 3 times 4 and 5 times 4. So the first one is 5 times 4, that makes 20, and 3 times 4, that makes 12. Now that we already have the same denominator, we can compare the numerators. So we have 7 here and 20. Is 7 greater than 20? No, it's false. Okay, so the result for Q, for this proposition Q, is completely false. Okay, because 7 is not greater than 20. This is the opposite. Would be 7 is less than 20. So in this case, the proposition is false. But did we finish the example? No, we haven't finished. Because there is missing, we have to find, first of all, we have to find the negation of P, and we already have Q. Q is false. We already have this. So this result will be false, okay? Now, what is missing? The negation of P, but here we have the result of P, that is true. So what is the negation of P? We're going to find it. So let's find the negation of P, all right? And what is the negation of P? Is the opposite answer. So if we had the proposition is true, the negation of P will be false, okay? Remember, denial of propositions. So this negation of P will be false. This result is false, okay? So we already have this, and this is equivalent to this, okay? And we are missing to find false and false, okay? So what is this? What is false and false? So we have to find here in the truth table false and false, and we get false and false, will be false. Okay, this will be the result. Okay, false and false is false. In this case, the final answer is false. Okay, this is completely false. This is our final answer. All right. Okay, very good, guys. So we already know how to use the truth table by using some propositions with mathematical expressions. Remember, once again, we have to solve the operations that we have here, and finally we compare if this is true or false. 2 is less than 12. Of course it's true, so we already have this. And in this case that we have fractions, we have to solve all this operation. 1 over 3 plus 1 over 4. We solve this, we find the least common denominator, we multiply by the numbers to get the LCD, and then we compare the final answer, 7 over 12, with 20 over 12. And we realize that this is false. So finally, we have to find the denial of P, negation of P. If P is true, the negation of P is false. And we use the truth table to compare false and false, that makes false. All right? Okay, guys, very good. So let's see an additional example, which is really easy also. In this case, we have two propositions. We have P, 7 minus 8 plus 6 equals 12. We have to find out if that's true or false. And in the other hand, we have, given the sets A, 2 and 3, and B, 1 and 3, we have to find if A intersected with B is 3. We don't know it, so we are going to find it. So the first one, we're going to find this truth value. Okay, so we solve this operation, 7 minus 8, that makes minus 1. Okay, minus 1 plus 6, that makes 5, equals 12. So you can see clearly that this is completely false because 5 is different to 12. So P, finally here, P, the proposition P is false. Okay, so we already have the first truth value. Now let's continue with the next one. This is very easy too. Given the sets A and B, here are A intersected with B is 3. Remember, once again, the intersection are the elements in common. What elements in common do we have between 2, 3, and 1 and 3? Of course, the only element in common is 3. So A intersected with B is 3. So is that true or false? This is completely true. Okay, so Q, the truth value is true. Okay, very easy. We have false and Q and true. But look at the question. We have to find P and Q. So we have to find P and Q will be false. That would be the first one. Would be false. And by following this, Q, that is true. Okay, so we have to find this truth value, false and true, and we look at our truth table that we are always going to use the conjunction table, and here we find that false and true will be false. So the final answer for this will be false. Okay, this is our final answer for these propositions. All right, this is our final answer. Okay, guys, so that's it. This is a conjunction. Remember, we are always going to use this table for conjunction. First of all, find the truth value. We are going to find if the proposition is true or false with this and with this. Here we find that it's false and this is true. And finally, we compare with the truth table if P and Q, false and true, and we realize that false and true is false. All right, so little by little, proposition by proposition. Okay, and that's it, guys. So I hope you really understood, and see you later with another video. If you have any questions, please let me know by email, and see you on next week on Thursday in the virtual class, okay? So see you later, bye bye, take care.